All right, so we are talking about prime and composite numbers. So prime numbers are a natural number that has exactly two different factors, and those are 1 in itself. So these are the prime numbers. So 2, 3, 5, 7, 11, 13, 17, and it continues on. 1 is not a prime number because it's only divisible by itself. So it is not. And any multiples of these numbers would not be prime numbers because they would be divisible by themselves and other numbers. So we are also looking at composite numbers. Composite numbers are a natural number that is not a prime number and not 1. So like 4 is divisible by 1, 4, and also 2. 6 is divisible by 1 and 6, but also 2 and 3. 8 is divisible by 1 and 8, but also 2 and 4. 9 is divisible by 1 and 9, but also 3. So if they're divisible by something other than just 1 in themselves, then they are considered a composite number. So let's talk about prime factorization, and then we'll do some examples. So prime factorization is where all the factors of a number are prime numbers. Repeating factors can be written with exponents. So if we have the example of 12, and it can factor out to be 2 times 6, well, 2 is a prime number, but 6 is not. 6 becomes 2 times 3. So that means we have 2 times 2 times 3, which equals, we have 2 2's, so that makes it 2 squared times 3. So let's go look at some examples of these so that we can have a further understanding. So for example 1, we want to know, are these prime or composite? So are these numbers prime or composite? So the first one we want to look at is 3. If I do a prime factorization 3, or of 3, then I only get 1 times 3. So that tells us this is going to be prime. If I look at the number 9, 9 is divisible by 3 times 3. So I'm only going to write the 1 in the number if it's a prime number. If it's not, I'm looking at what else can I do that by. I now know that 3 would be 1 times 3. So this tells me this one is going to be composite. If I want to list the factors, I could. So I could say that the factors, let's write factors over here, in the first problem would be 1, 3. In this one, it would be 1, 3, 9. You wouldn't repeat the factors. We're not doing prime factorization where we'll group them. We're just looking at what they all are. So this tells me this is composite. If we look at 11, 11 is only divisible by 1 in itself. The factors are only going to be 1 and 11, and this tells me it's going to be prime. If we look at 26, well, 26 is an even number, so I know it divides by 2. That would be 2 times 13. So my factors, because 13 is prime and so is 2, would be 1, 2, 13, and 26. 1 times 26 gets us 26. 2 times 13 gets us 26. Because I have more than just 1 in itself, it's going to be composite. All right, so let's go look at some prime factorization. So this will be example 2. We're looking at doing the prime factorization of some examples. So for the first one, if we look at part A, the number is 12. I know it is even, so it divides by 2. 2 times 6 gets me 12. And now I need to break down 6. 6 would be 2 times 3. So my factors, and you got to make sure you include each of them, but not the numbers you refactored. So we have a 2 times a 2 times a 3, and that tells me I have 2 2's, so 2 squared times 3. Let's look at another one. So if we have 45, well, it ends in 5, so I know it divides by 5. So 5 times 9 is 45. I can then break up 9 because 5 is a prime number. 9 would be 3 times 3. So I'm going to end up with 3 times 3 times 5. You don't have to put them in numerical order, but it helps if you kind of group them that way so you can see how many you have of each. I have 2 3's, so this will be 3 squared times 5. And you can check this with your calculator. You could take it and multiply 3 times 3 is 9 times 5 is 45. So you can make sure you actually got all the factors correct. Now we could have done this same example in another way. So let's do 45 another time. I can try a different prime. Let's say I don't realize it divides by 5, but I realize it divides by 3. 3 times 15 is 45. 3 is a prime number, but 15 is not. That is 3 times 5. So now I still have 3 times 3 times 5, which will get me 3 squared times 5. So no matter which way you do it, you will get the exact same prime factorization at the end. It doesn't matter what factors you choose to begin with. Looking at the 12, instead of doing 2, we could have done 3 times 4. And then 4 would have broken down to 2 times 2, and we would have the 3 there. So it doesn't matter which factor you decide to do first. It is always going to work itself out to be the same thing. All right, let's look at another example. So if we look at example C, we have 8. 8 is divisible by 2, so 2 times 4 gets me 8. 2 is prime, but 4 is not. 4 is 2 times 2. So for my factors, I have 2 times 2 times 2, which means I have 3 2's. So with those 3 2's, I will end up with 2 to the third. All right, so for D, let's look at 18. 18, you could do 2 times 9, 3 times 6. It does not matter. Like I showed you on 45, you're going to get the same answer. I'm going to do 2 times 9. Well, 2 is prime. 9 is not. It is 3 times 3. So I end up with 2 times 3 times 3, which will be 2 times 3 squared because I have 2 3's. Now sometimes we're going to have bigger numbers. So let's look at example 2. Example 3. So we're still doing prime factorizations. And let's look at 700. That is a big number. So for 700, if it ends in a 0, you can divide it by 10. If it ends in 2 zeros, you could divide it by 100. So let's go with 100. So 7 times 100, if you'd done 10, it would be 70 times 10. You can go either way. Like I said, you'll get to the same answer. 7 is a prime number, but 100 is not. It is 2 times 50. You could have done 5 times 20, 4 times 25. It doesn't matter. You're going to get to the same answer. 50, we could do 5 times 10, or we can do 2 times 25. And 25 would be 5 times 5. So now for our factors, we've got 2, 2, 5, 5, and 7. So now we have 2 squared times 5 squared times 7. And no matter what way you divided those out, you would get there. All right, let's look at another one. If we have 216, I don't know a lot about this one, but I know that it's an even number, so I know it will divide by 2. And you can use your calculator on these. So 2 times 108. I don't know what 108 is divisible by, but I know it divides by 2 because it's an even number, because it ends in an even number. So 2 times 54. 54 again is even, so 2 times 27. You could have also done 6 times 9. 27 is divisible by 3 times 9, and then 9 becomes 3 times 3. So we're looking at 3 2s and 3 3s. So if I'm looking at my factors, I have 2 times 2 times 2, 3 times 3 times 3. So that means I have 2 to the third times 3 to the third. And that totals, if I multiply those all out, I should get back to 216. All right, let's look at part C. If we look at 120, 120 ends in a 0, so I know it's divisible by 10. So I can get 10 times 12 gets me 120. 10 becomes 2 times 5. And 12 we can do 3 times 4 or 2 times 6. It does not matter. We did 2 times 6 earlier, so this time let's do 3 times 4 just to mix it up. 2 is a prime number, 5 is a prime number, 3 is a prime number, 4 is not. It is 2 times 2. So looking at our factors, we have 2 times 2 times 2 times 3 times 5. And again, you might want to multiply those out so that you can make sure that when you multiply them, you get back to 120 and you're not missing one of your factors. So this tells us we have 2 to the third times 3 times 5 as our factors. All right, let's look at one more. We've got 234. Again, I don't know what it divides by, but it divides by 2, and I get 2 times 117. Well, I'm not sure what 117 divides by, so if it doesn't divide by 2, try a 3. This actually does divide by 3, and you get 3 times 39. So keep trying a prime number till you get to something that works. Well, 39 is divisible by 3, and I get 3 times 13. So now I have 2 times 3 times 3 times 13, which will get me 2 times 3 squared times 13. And again, you can multiply those out until you find that you have all prime numbers, and then multiply it out to make sure you're getting back to your original number.